theme is on the smart factory evolution. We would have heard lots about it. We have done for the past years, and again, walking over the trade show here, it's a prominent theme that we're seeing on lots of stands. I've got some very knowledgeable gentlemen with me today. I'm very proud to have Michael Ford from Aegis and Keith from Ixlon with me, Keith Bryant. Welcome, thank you for turning up. So, the smart factory. For me, the essence of the smart factory, the underlying essence is the data that's generated. We're talking about data that's generated by machines, by all sorts of networks of machines. But you know, where's that coming from, and is all of that data relevant, and how is it being analyzed to be then therefore useful? I think that's the main theme here. So if I can start with you to give your thought.
When I was learning how to program computers many, many years ago, there was a term that came up, I don't know if you know it, garbage in, garbage out. We've got a lot of garbage in the industry right now. You know, for a lot of looking back historically, you see machines giving out information. About 80% of it had no meaning in isolation. Putting information together and sharing it between different aspects, different machines in the line, and building a qualified event. That is then a piece of data that you can action. You can show it in an added value chart, you can put it up into the cloud, and it can be analyzed. But if you don't go through that process of qualification, you just end up with bits and bytes of data that may have seemed fine at the time, but actually later on they have no meaning. So today we're seeing, of course, the evolution of that, and from the machines like you have, a huge and vast amount of data that's coming out that is good, actionable data. But how do we get that into the hands of the people who can use it and can understand it and will create value from it? So that is the challenge we have.
Your machines generate a lot of that data. So how are you dealing with that, knowing what data it should be communicating to the next system, to the next system, and the next system?
Yeah, it is. It's a very big problem for let's say for the people that are on the line and the people traditionally like us who are at line or offline. And it's great, this wonderful theory of having machines talking to each other, but they have to be saying something. Yeah, just talking to each other doesn't bring any benefit, doesn't bring any value. And you know, if you're looking to improve the yield of what you're doing, which is the angle that we come from, I mean, with the smart factory, there are a lot of other things that lead back into purchasing and lead back into other areas of the factory. But the main focus that we have is on improving quality to improve yield, to reduce cost. And there you have to have, exactly as you've said, you need accurate data from the inline machines. And one of my colleagues describes it very well. He says, inspection machines within a production environment are becoming sensors. And those sensors produce information, and that information has to be acted on by another system for any improvements to be made. In other words, if an inline AOI machine says this component is always misplaced, somebody has to get the message to the pick and place machine to change the settings so that it's no longer misplaced. And that's that's the simple loop, yeah? And it's being able to analyze that data and find a way of shifting it back. And at the moment, it's through stuff like these guys do, where you have a good control system, you have a good, let's call it a management information system. But it's also something that you can act on when you see the information. You know, when I started in the industry, we used to have a meeting every Friday, and we looked at how the production had gone for a week. And we found out things that were wrong that we could put right for next week. And for a lot of people, this was, you know, really revolutionary. And we were working week to week. So something that was wrong 5 days ago, we were fixing 5 days later. We're in that beautiful system now where with this great information that we get continually from the line, we can work almost in real time. But it's great. The data has to be accurate, then it has to be actioned. And they're the key things that I'm pleased to say are starting to happen now. You know, we started with this perfect view of a lights out factory with no people and all the machines recalibrating themselves and everything else. And people have now realized that, utopia is a long way away.
And maybe they don't want that. They still want the people aspect in it. And I guess that's also part of the analysis and the actionable response that you give from the data information. Now, you mentioned garbage. If it's garbage, it's garbage. But garbage to some is valuable, very valuable to others. How do you decide what really is garbage and what isn't?
It's an interesting question because when we were, Aegis is part of now 320 companies that are working toward the Connected Factory Exchange standard. So when we set out to do this, we realized that other standards are merely moving information from one point to another. And there was no real value in that because different machines speaking different language. So we set us about how do we define a common language? Now, consider the Earth right now. There are 3,000 different languages being spoken by people simultaneously right now. Now, how do we go about teaching each of them to speak just one language? It's almost impossible. But that's kind of what we're doing now with the machines. Somebody has to come along and define what is the meaningful information about any event that happens on any machine. And some of the machines, for example, that you have, they're quite unique. They do something which adds a specific value that differentiates it from anybody else's machine. How are you supposed to capture that in a standard? And the result is 380 people working together, the best in the industry, to come along with a neutral language through which we can communicate and we can provide the value from machine to machine, machine to anywhere else in the factory. It's been a hard job, to be fair. But we are very, very close now to publishing this standard. We expect it's going to be done in September this year. We're going to see the revolution really start when that comes out.
Mm-hmm. So essentially you're creating a dictionary for the industry with words with information in it that can be interpreted.
Exactly. It's got to be plug and play.
Yeah.
It's not plug and translate.
Yeah.
It's got to actually bring the information that you want and be able to take decisions on it. And for a lot of years, I think the information coming from the kind of test systems that we see, the inspection systems, we've not been able to use it effectively. And now we're going to open a door for you guys to be able to see that information, because pick and place doesn't create any information. It just tells you what you've done. It doesn't measure how well you did it. So, people are buying inspection machines to find defects. That's kind of a negative connotation. Now, in the future, they're going to be buying your machines to prevent defects from occurring in the first place through the analysis of the data that you provide using CFX. This is the revolution in quality.
Yeah, what everybody wants to do is to continually work within what we call the process window. You have an upper limit that's acceptable, you have a lower limit that's acceptable. If you keep everything running in between that, you have a very capable process. What you don't want to be doing is saying, all these things have failed, now I need to put my process right. Yeah, that's the step forward that this information gives us. It's continual real-time monitoring of what's happening. So we can, we as operators or engineers can set acceptable limits, and then we can control what's happening in the process to stick within these acceptable limits. And if we've chosen the right limits, we get perfect yield.
Final question, therefore, with all this communication going on, communication should often lead to understanding, which now goes into machine learning scenario. Is this the next phase where actually the data generated that is analyzed, that reflects that meeting you used to have where it took 5 days to react, now it's sort of instant? Are we at a crossroads where that data now is becoming useful data for the machines, so next time it doesn't even make that mistake?
We're heading there, yeah. It needs to be done in a series of steps. The first step is to get the data, believe in it, trust it, see that its value is really as we say. Then you get to a state where it's augmenting human decision-making. So people are seeing the visibility of the digital rendition of the factory, and we're saying, yeah, do this, do that, do the other, and that replaces the meeting. Will we ever get to a state where we don't need the human involvement? I think it's a fair way off. And we need to go through the necessary steps because there are hundreds of examples of how we're going to use this data. We need to go through and enhance the way the factories work, becoming a lot more flexible, a lot more productive, even with high mix, being able to deliver on time a very large quantity of products of different types. This will be achievable now in the very near future, but we go through these stages of learning and trusting the data and using the data to automate our decisions.
So would it be a scenario maybe where obviously the human is still involved, but the machine comes up with a little message saying, whoops, we've been here before, done this, you corrected it in one way or another, and give you options through that?
Yeah, it's a potential. You know, I mean, one of the things that we're saying at the moment is, if we're only working with algorithms, there's only one answer. You know, you have an engineer stood by a printing machine, and his print is a little bit, a few areas are missing. He can tell you 6 reasons why that may be happening, and they're all valid reasons. But an algorithm is going to give you one. And until we can get, let's jump and use the word artificial intelligence. And you know, we are one of the companies who are actually working on trying to get artificial intelligence within our own systems to reduce the reliability, let's say the reliance on the operators. But again, it's a long way off, but people are starting to move in that direction.
And in the standard that you're creating, is artificial intelligence already a subject that you're discussing or taking into consideration?
Yes, it is.
Yes.
But we have to be careful about AI because we're not talking about Terminators or things like that. We're talking about algorithms that don't just create one answer. They can adapt themselves to be able to take into account a large number of variables that they never had access to before. Because a human, basically, we have sensors and we can understand things in a way that machines can't. But the machines will catch up. And the whole purpose of the definition of data in CFX is to allow that kind of visibility in a digital world so that algorithms can see far more information than they've seen before, and they can start to behave more like intelligent people. So I think we're going to get further along the way as time goes on with this. Yeah.
And it's an evolution.
Yeah, it really is.
Oh, very much.
Yeah. So we're very short on time, so I just want to open up to the floor if anybody's got any questions on the subject. We've got 1 or 2 minutes left about data in the smart factory. If not, then I'd like to thank the panel for your participation. As always, great to see you here. And yes, good luck with the launches and the developments that you're doing to the machines. Thank you.
Thanks very much.
Thank you.